In computing, programming relies heavily on the concept of data types, which are fundamental for organizing, processing, and manipulating data effectively. Data types tell a computer what kind of data it is dealing with, ensuring operations are performed correctly and efficiently. Using the correct data type not only makes programs more efficient, but also prevents errors that could arise from inappropriate data handling. There are 5 main data types commonly used in programming: integers, floats, characters, strings, and booleans. Each of these serves a specific purpose, tailored to handle distinct types of information. The first data type, integers, is used for whole numbers. These are numbers without a fractional or decimal part, such as 3, 15, or 2024. Integers are ideal for data where precision matters, but no fractional value is required, such as counting items, calculating age, or identifying an index in a list. For example, if you were programming a game, you might use an integer to track a player's score because a score is typically a whole number. Floats, or floating point numbers, handle decimal or fractional numbers, such as 3.14, 0.5, or 7.0. They are essential for calculations requiring precision and are often used in financial applications, scientific computations, and any situation involving measurements like distance or weight. For example, if you were building a program to calculate currency exchange rates or scientific formulas, floats would be crucial to ensure accurate results. Characters represent single letters, digits, or symbols. These are stored as individual units of text, such as A, B, or 7. While characters might seem simple, they are fundamental when dealing with text-based operations. For instance, a character data type could store the initial of a person's name or a single key press input from a user. Strings, by contrast, are sequences of characters, enabling the storage and manipulation of longer pieces of text. A string might contain words, sentences, or even a mix of letters, numbers, and symbols, such as Hello World, 123 ABC, or 5.99. Strings are crucial in applications where textual data is processed, such as storing usernames, displaying messages, or generating reports. For instance, in an online shopping application, strings would be used to store product names and descriptions. Finally, booleans are data types that can only hold one of 2 values, true or false. These are often used in decision-making processes within a program. For example, a boolean might be used to check whether a user is logged in or not, or whether a particular condition has been met in a loop or an if-else statement. Their simplicity and efficiency make them indispensable in logical operations and control flow. Choosing the correct data type is a critical aspect of programming. Using the wrong type can lead to inefficiencies or errors. For example, storing numbers as strings instead of integers or floats could make calculations cumbersome or impossible, as text cannot be added or multiplied mathematically. Conversely, using a float when only whole numbers are needed might waste memory and computational resources. Booleans, though compact, would be unsuitable for storing anything beyond true or false, such as text or numbers. In practice, programming languages enforce the use of correct data types through declarations or implicit assignment. For instance, in strongly typed languages like Java or C++, a variable must be declared with its type before use. This declaration ensures that the data stored in the variable adheres to the type's rules, preventing errors during compilation or runtime. In contrast, loosely typed languages like Python can determine the data type dynamically based on the value assigned. Regardless of the approach, the programmer must still understand the data's nature to ensure proper handling. In summary, integers, floats, characters, strings, and booleans are the 5 main data types, each serving a unique role in managing and processing information. Correctly identifying and applying these data types allows programs to function efficiently and accurately, ensuring that operations are carried out as intended and preventing issues that could arise from mismatched data. This understanding is an essential skill for any programmer, forming the foundation of effective and reliable code.